Welcome to this discussion. We've been given this equation that we determine and classify the stationary point of a function f of xy equals to x cubed plus y squared minus 5xy minus 5y plus 10. Now the key points here are we determine and classify the stationary points. Now the stationary points they can either be at a minima or a maximum. So that's what they want us to determine in this equation. Now, with the stationary values and stationary points, so the first thing is for us to find out whether there is a true maximum or minimum point. And we normally use this expression. Or before that, I will now this is the equation. Now I will let z equals to f of x for easier working, so that then the equation becomes z equals to x cubed plus y squared minus 5xy minus 5y plus 10. Now, for us to confirm whether we have a maximum or a minimum true value, then we confirm by this expression. So we shall confirm with this expression that when we take the product of del 2 del z squared del 2z del x squared times del 2z del y squared minus del 2z del x del y, and then we square it, when the result is greater than 0, then it means we have a true maximum or minimum point. Okay, now we shall get the partial derivative of that equation with respect to x and with respect to y. So with respect to x, we get del z del x. So when you differentiate x cubed, we get 3x squared. Then this will be 0 because remember when we are carrying out partial derivative, one variable is taken as a constant as we differentiate the other. Therefore, this one is 0. Then minus, when you differentiate x here, you get 1. 1 times 5 times y will remain with 5y. So it will be minus 5y. Then this one will be 0. So this is del z del x. We can now differentiate this one for the second time with respect to x, which will be del 2z then del x squared. We differentiate this equation with respect to x again. It will be 2 times 3, which is 6, which will be 6x. This one is 0. Then we can also get the partial derivative with respect to y, that is del z del y. This will be 0. When you differentiate y squared, you get 2y minus, when you differentiate y there, you get 1. 1 times 5x will remain with 5x. And then when you differentiate negative 5y, will remain with 5 minus 5. That is 0. Then we can differentiate this one equation again with respect to y, that is del 2z del y squared. This equals to, when you differentiate this y, you get 1 times 2. We have 2. This is 0. That is 0. Now, Once we have the two values, now we know that at minimum or at maximum, the gradient is equal to 0. So when you differentiate like this, so at a maximum, either we have this or we have that. But the value of the gradient equals to 0. That is, we are saying at a maximum or minimum, the two equations are equal to 0. So 3x squared minus 5y equals to 0. 2y minus 5x will be equal to, when 5 goes with the other side, will be equal to 5. So we can now solve the two equations to get the value of x and y, either at a maximum or at a minimum. Now, this is question 1, that is question 2. I can make 2y the subject in this equation. 2y equals to 5x crosses to the other side will be now 5 plus 5x, meaning that y equals to 5 plus 5x all over 2. Therefore, where there is y in the first equation, I replace with 5 plus 5x plus 2. So this equation becomes 3x squared minus 5 now into 5 plus 5x all over 2 equals to 0. Now I multiply through by 2 through the equation. So 2 times 3, I have 6x squared minus, here I have minus 25x minus 25 equals to 0. So this is a quadratic equation. I can use the quadratic formula to get the value of x. Let me rub here. Now, with the equation is x is given by minus b plus or minus the square root of b squared minus 4ac over 2a. Now from the equation, a equals to 6, b equals negative 25, c equals negative 25. Therefore, x equals, now we substitute b with negative 25, so we have negative 25 plus or minus negative 25 squared, this is 625, minus 4 times a, which is 6, times negative 25, which is c, like that. Then all over 12, 2 times 6. So this equals to, now negative and negative, it will be now 25 plus or minus the square root of now 625. This negative and this will be positive, so we have plus. Now it will be 4 times 6 times 25 all over 12. Now this equals to 25 plus or minus, you can multiply that. 4 times 6 times 25 plus 625. So this equals to the square root of 12 all over 12. And rub here. Now the square root of this, the square root of the answer there equals to 35. So this x equals to 25 plus or minus that 5 all over 12. So from here we have two values of x. We have x1 equals to 25 plus that 5. We have 60 all over 12. This is equals to 5. And then x2 equals to, you now subtract 25 minus that 5. We have negative 10 all over 12, which equals to 2 there is 5 and 6. So two values of x, x1 equals to 5, x2 equals to negative 5 all over 6. Now, after getting now the values of x, we can use the when x is equal to 1, and then we go back to the two equations. Now, even at this point, we say that y equals to 5x, 5 plus 5x all over 2. So we can get the value of y from here. Can now rub this. Can rub that. Y equals to 5 plus, now we have the value of x, which is 5. So 5 times 5 all over 2. 5 times 5, 25 plus 5, 30 divided by 2, 15. So we are saying that we have the point, we have 5, and then we have 15. Now, now we have this point, but we don't know whether this one is maximum or minimum. But for us to confirm whether this one is minimum or maximum, we normally use this. You take del x, del 2z, del x squared, and del 2z, del y squared. If all of them are positive, then the given point AP, will be at minimum. This and this, both of them are positive, then this point will be at a minimum. When this and this are negative, then this point will be at a maximum. Now from our equation, you can see that we have 6x and then we have 2. So both of them are positive. What does it mean? It means that this is at a minimum. This is at a minimum. But we can also confirm whether we have a true maximum or minimum point by using this expression, that del 2z del x squared times del 2z del y squared minus this must be greater than, if it's greater than 0, then we have a true maximum or minimum. But in our case, it's now a true minimum because this and this, both of them are positive, and we have said if they are positive, then this point is at a minimum. Now we can confirm this. So we have del 2z del x squared times del 2x, which is that one, so it's 6 dot del 2z del y squared is 2 minus, now we need to get this one, del 2z del x del y is the same as this. The same as this. We get the partial derivative of del z del y with respect to x. But what is del z del y? Del z del y, we have wrapped, but we can still write it here. Del z del y, this equation will be, we have 2y 2y minus 5x, then minus 5. So that is del y del z. So this, we are getting the partial derivative of that with respect to x. This is 0, so we have negative 5 with respect to x. So it will be negative 5. So negative 5 squared. So we have minus negative 5 then squared. So, but remember, this is at this point. What is the value of x at this point? 5. So this will be 6 times 5 times 2 minus this will be 25. 6 times 5, 30. 30 times 2, we have 60 minus 25. 60 minus 25, we have, I think that 5. We have that 5, which is greater than 0, Therefore, this one is a true minimum point. It's a true minimum point. Now, after getting this point, we now need to get the actual minimum point. Let me wrap this. The actual minimum point or value. We write it as this, which equals to, now we write the whole equation, x cubed plus y squared minus 5xy minus 5y plus 10. Now the actual minimum value, we now substitute with these values. Where there is x, we put there 5. Where there is y, we put there 15. So this will be equal to, now this x cubed will be 5 cubed plus 15 squared minus 5 times 5 times 15, then minus 5 times 5 plus 10. Let us see the actual minimum value. So we have 5 cubed, 5 cubed plus 15 squared minus 5 times 5 times 15 minus 5 times 5 plus 10. Um, 15 squared plus 5 cubed minus 5 times 5 times 15 then minus 25 plus 10. Minus, let me confirm first, 5 cubed, 5 cubed, this is 5 cubed, this is equals to 125 minus 15 is plus 225, that is 15 squared, 225, then minus 5 times 5 times 15 minus 375 then minus 25 plus 10, 125 plus 225 minus 375 minus 25 plus 10 minus 40. So what we are saying is that in this equation, they wanted us to determine and classify. So we have determined that this one is a true minimum value of this function, and the actual minimum value is negative 40. Is negative 40. So thank you for watching and listening.